Hi friends, welcome to a new section of Mechan Tech Zone. Today we'll be discussing about different types of stresses. So what are different types of stresses? How we can find out the different types of stresses? What is the application of different types of stresses? Those things will be discussed in this chapter. So welcome to my channel Mechan Tech Zone. So the first type of stress, let us move to the first type of stress. It is tensile stress. Tensile stress is a stress which is developed in a member due to a tensile load. The stress under the effect of a tensile load is termed as tensile stress. So let us see the figure here. A circular rod is acted upon by a tensile load P and having an area of A1. Why it is called a tensile load? Because the effect of this load is to pull the shaft or pull the member. As a result of that, that is called a tensile load. As a result of that, what happens is that the length of the beam or length of the member increased and the area has decreased. So the length increased and the area has decreased. So under the action of this tensile load, the member has elongated. So the member has developed tensile stress. So we can define tensile stress as sigma T. T stands for tension. It is given by P by A1, where P is the load, tensile load applied, and A1 is the resisting area. In this case, the area is, so you all know the circular cross section, the area is pi by 4 d square. That is tensile stress. The second one is compressive stress. Compressive stress is just opposite to what is tensile stress. We can see that the only difference in the second figure is the direction of load P is such that it will compress the member. It will compress or push the member. So as a result of that, what happens is that the length of the member has decreased and area has increased. So under this state, the member is said to develop compressive stress. It is given by sigma C. C stands for compression, which is equal to P by A. P is the load and A1 is the resisting area. That is compressive stress. So the third type of stress is shear stress. So the first two cases, we can see that the direction of application of load was along the axis of the member. You can see the direction of application of the load was along the axis of the member. It was perpendicular to the area of cross section. This area of cross section is A. The load was acting perpendicular to the area of cross section. It was acting along the axis of the member. In this case also, it is like that. The load is acting perpendicular to the area of cross section. This is perpendicular acting area of cross section and along the axis of the member. But in the case of a shear stress, we can see that the force would be acting tangential to the area. That is the importance, or that is the difference between the first two types of stresses and the shear stress. In the case of shear stress, the force will be acting tangential to the area. We can see here a circular beam is fixed at the bottom having a length of L1 and area of A. A load P is acted on the upper face of the beam in the tangential direction. So as a result, what happens? A tangential stress or a shear stress is developed inside the material. So as a result of that, the material will deform like shown in this figure. So this rigid line corresponds to the deformed position and the dotted line corresponds to the initial position. So under the application of this load P, the material has sheared by an angle theta, or the member has sheared by an angle theta. That is what is shear stress. So the shear stress is such that it will be always acting tangential to the surface and it is shearing the plane. So that is what is called shear stress. So I think the concept of tensile stress, compressive stress and shear stress is clear to you. Next day we will be coming with bending stress and torsional stress. So stay tuned for more videos and don't forget to subscribe to the channel and also press the bell icon so that you will be getting the next upcoming topics without missing. Thank you.